two approaches can be used to find code words in convolutional encoding process. For a given convolutional encoder, we can use either time domain approach or a transform domain approach. Also, we can find these code words or output of the encoder from state diagram, trellis diagram, and code tree diagrams. So in time domain approach, how we carry out this? We have this statement, basic conceptual statement. Convolution in time domain is same as multiplication in frequency domain. So here we use convolution in time domain. The encoder output is obtained by the convolution of the input sequence and impulse response of the encoder. That is why you call this coding process as convolutional coding. Suppose let us consider 212 convolutional encoder. It has two outputs and the first generator function. So this first generator function is connected to first stage, all the stages of the encoder. So this will be 1, this will be 1, this will be 1. The coefficients are tap gains. So this will be 1, 1, 1. So second one, this is 1, this is 0, this is 1. The second generator is connected to only first stage and the second stage of the last stage of the encoder. So here G1 and G2, here G1 and G2, they are known as generator sequences of the convolutional encoder. These generator sequences are also known as impulse responses of the encoder. So here 101, 1 means there is a connection and 0 means the corresponding flip-flop is not connected to the function generator. Function generator means modulo 2 adder. The problem statement is below figure depicts half rate constraint length 1. So the state of the encoder will be only one flip-flop is used to, one bit is used to represent state of the encoder. Convolutional encoder. Find the encoder output using this time domain approach for the given input sequence. So here we know this is the we know generator functions. This is the impulse response of first output, impulse response of the second output, and the coefficients are given. Here this is 1, this is 0. Here this is 1, 1. So we simply multiply the convolution of the input sequence and this impulse responses. So this is simple to calculate the output of the time domain approach to find the encoder output is given below. Initially shift register is at all 0 state. That means this will be 0 and also this will be 0. So the given input bit stream is 1, 1, 1, 0, 1. The first bit, incoming bit is 1. In step 1, incoming bit message is 1. And the state of the shift register is 0, 0, 0. After applying one clock pulse, this 1 comes to this place and this 1 comes to this place, 0 comes to this place, and this 0 will be discarded. So the state of the shift register becomes 1, 0. So we can find now if it becomes 1, 0. So we can find x1 and x2 using these formulas, because from the diagram we can say x1 is equal to msg, x2 is equal to msg plus m2. This is the modulo 2 addition. The rules for modulo 2 addition are given here. 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 will become 0. Because modulo 2 addition is nothing but exclusive or logic operation. For odd number of inputs, the output will be 0. Sorry, output will be 1. For even number of inputs, output will be 0, or you can also find the output from this formula. A plus B, A exclusive B will be A bar B plus A B bar. So this represents modulo 2 addition, also represents exclusive OR operation. So now for step 1 we got the output is 1 1. So now in step 2 the incoming message bit is again 1 and the state of the shift register is 1 0, and after applying the clock pulse this one enters here, this one enters here, and this 0 will be discarded. So the output, the state of the shift register will be 1 1 1. So using these formulas again we can find the output to 1 0. Now again the third message bit will be 1 and the state of the shift register will be 1 1. So after shifting, after we apply the clock pulse, shifting right by 1 bit, we get 1 1 and the output will be 1 0. Similarly we can get for message 0 the output will be 0 1, for message 1 the output will be 1 0, and finally we can reproduce the output of the convolutional encoder. This one is converted to 1 1 and so on. So this is the encoder output for the given input to sequence. If you want PDF files of my video lectures, please visit www.engineerstutor.com. For PDF link, see description of the video. You can also write to me at rkgopal2020@gmail.com for any doubts and queries.